Okay, now we are going to move on to the next concept called as another one, that is graph based protocols. In order to know the multiple granularity concept, you should know about the graph based protocols first. Okay, as you already know, like a graph will be having the vertices and the edges, isn't it? So vertices can be considered as the transactions, and edges are nothing but if the one transaction is waiting for the other transaction, then an edge is going to be formed. That is, one transaction is waiting for a data item that is held by the other transaction. Then an edge has been created between the two transactions. This is all about the information, right? Now, whatever the schedules we are unable to find out with the two-phase, if the other technique which can be used is nothing but the graph-based protocols or an alternative to the two-phase locking protocols. Okay, so I can say instead of your two-phase locking protocols, you can use this method. Okay, so now this method, if at all you want to implement some additional information, you should have in prior. Okay, what is that prior information you should have? You should maintain the order in which the data items will be accessed. Means when A will be accessed, when B will be accessed, when C data item will be accessed, that order you should know which data item should be accessed first. If at all you know that order, then only you can implement the graph based protocol. Otherwise, we have to simply shift on to the two-phase locking protocol itself. Okay, so this protocol needs to know the order in which the data items has to be accessed. Now, in order to know the order, what structure you are going to form, you need to have a hierarchical structure, isn't it? One after the other. After A, B should be accessed. After B, C should be accessed. That information we should know. So which structure, which data structure will be helping us to know that particular hierarchical order? Can anyone tell me? Which structure will be helping us in order to know the hierarchical order? Which data structure? Best data structure?
Tree.
Like parent information, child information. Yes, I got the answer, I think.
Tree.
Very good. Tree is the data structure by which we'll be knowing the order, hierarchical order. So here, okay. Yeah, though we have to make sure that order has to be maintained. Now here what kind of information we should have? We should have the set of all the data items first. Okay, so what information we should have? All the set of the data items should be having. And if suppose TI transaction and TD's transaction, both the two transactions want to read the data item, okay, then which should be given accessing first? Okay, so if TI is going to, an edge has been formed between DI and DJ. What does this mean? Both DI and DJ must access DI before DJ, isn't it? That is, the first TI transaction must use the data item, then only the TJ transaction must use the data item, isn't it? So that information we should maintain. Okay, so you said it is tree structure is the correct one. Now you can see. Now, if I by looking at, are you able to look at the tree structure? Yes. Tree protocol. Okay, fine. Now, my simple question is, if at all I want to access the data item B, I want to log this B, then there is a condition that, and only exclusive logs are only allowed here. No shared logs in the graph-based protocols. Only exclusive logs have to be used. You can see the question. The only lock instruction allowed is lock. That is, exclusive lock only will be allowed. No other shared logs can be allowed. Is it clear for you? Okay. Now, if I want to read data item B, then I want to apply the lock on B. So if I want to apply the lock on B, my condition is the parent of B also must be logged. Means which data item has to be logged? Can you please tell me?
A.
Very good. If I want to access the data item H, I want to access the data item H, I want to apply lock, then which data item also has to be acquired a lock?
E.
No, no. For D, I want to access. D is the child of, sorry, H is the child of D. So on D also lock must be applied. And whereas D is again a lock of, child of B. So here, what might be the drawback here? Can you please imagine?
by step parent should be logged.
More number of locks are going to be applied. The only drawback of this graph based protocol is we need to maintain the list of all the data items that are been linked, that are been logged, isn't it? So that is the thing, right? If I want to access any data item, the only data item that I can see or I can access is nothing but I have to log even the parent also. Okay, so then only I can access the data item. So yes, so this is how you can see the example. T10 transaction applied a lockup on B. Then it can automatically access the E, because E is the child of B. So automatically it got a lock on parent node itself, need not again acquire the lock, isn't it? So similarly, you can see another transaction. If it want to lock the H, before which lock has to be acquired, H is the child of D.
D.
So the transaction first, which lock on which data item it has to acquire the lock? First, it has to acquire the lock on D, then only it can acquire the lock on H. Okay, so this is how the transactions has to be. At least one parent node, it has to acquire the lock directly. It cannot access the child node. It has to be recognized by the parent. Okay, so at least one parent node, if it is going to acquire the lock, then they can access the data items. Okay, so this is the example of the graph based protocols. And even this graph based protocols also is suffering some of the problems. Maybe it is removing what this second protocol, what it is removing, it is ensuring the serializability, and also deadlock also not been found. As you can see, how the deadlock will be occurring, no transaction is waiting for the other transaction, isn't it? Only once when the transaction is been executed, then only the other transaction is going to get executed, isn't it? Once exclusive lock is been applied, దీంట్లో ఉండే లాక్స్ ఏంటమ్మా మనకి ఓన్లీ ఎక్స్క్లూజివ్ లాక్స్. ఒక్కసారి ఎక్స్క్లూజివ్ లాక్స్ యూజ్ చేస్తున్నామంటే మిగతా ట్రాన్సాక్షన్స్ ఏమైనా యూజ్ చేయగలవా? నువ్వు కదా. దట్ ఈస్ నో అదర్ ట్రాన్సాక్షన్ కెన్ యూజ్. Automatically, definitely deadlocks also will not be present. Have you got my point? Yes. Because ఇక్కడ మనకి షేర్డ్ లాక్స్ కానీ అలాంటి లాక్స్ ఏమీ లేవు. We have only exclusive locks. Exclusive locks ఇచ్చాము అని అంటే no other transaction is going to access, isn't it? So that's what we'll not be having any kind of the problem. Okay, so serializability has been achieved, deadlocks are not been seen, isn't it? But the drawback is this protocol does not guarantee recoverability. That is, if suppose I said the 1, 2, 3 transactions are there, second and third transaction are reading the data item which has been read by the first transaction, and unfortunately first transaction is failed, then we are unable to recover the second and third transactions. Okay, so that is the problem in the graph based protocols. Okay, so this was about the second kind of the protocol, graph based protocols, which assure serializability free from the deadlocks but cannot achieve the recoverability. Okay, so that is the problem of the thing. So how we are going to handle the deadlocks, this is the concept what we have to actually see. Okay, as we are running out of the time, I don't know why this is going to be happened. It is 12:33 right now, and within 7 minutes, I don't know to what extent I can cover. But please, yes, already you people know the concept of the deadlocks, right? So this is how what it has been happening. T1 transaction, T2 transaction, both wants to read the two data items. First T1 is reading A, and at the same time T2 is reading B. No problem arises, right? But if T2 transaction has not been released B and T1 transaction wants to read B, then what happens? Deadlock is going to be occur. This scenario or this table you can see, the schedule you can see with the deadlock, isn't it? T1 acquired lock on A, but it is not releasing the lock. But T2 has taken B, written B, and it is waiting for the lock on A, which was already present with the T1. This is the deadlock condition, isn't it? So can anyone tell me what are the methods to handle the deadlock handling methods? Yeah, these are the methods: prevention, detection, and recovery. Okay, so we can even the first thing what we want to try is nothing but we want to prevent it. Instead of occurring, we try to prevent the deadlock. Unfortunately, if we are going to have the deadlock, we try to recover from the deadlock. Okay, so in order to recover, first we need to detect how the deadlock has been occurred. We need to know the reason. What is the reason how the deadlock has been occurred? By knowing that reason, we can easily automatically recover from the deadlock. So these are the techniques or the methods used for handling the deadlock. Now let us see the first method, that is prevention method. So what is there in the prevention method? Uh, it ensures that the system will never enter into a deadlock. Okay, by using this method, we try to make sure that the system will never enter into the deadlock. So what techniques it is going to do, isn't it? So here in the deadlock prevention methods, what we are going to do is nothing but we are going to add the preemption. Okay, preemption means stopping. Suppose two transactions are there, T1, T2. T1 is using the same data item, T2 is also using the same data item, and both wants to execute. Now T1 is taking more time and T2 is been kept waiting. What we have to do? We want to make sure that more number of transactions are going to get executed. So what we do in this preemption method, we stop the T1 first if it is taking more time. Okay, and we start the second transaction. Okay, so the deadlock is not been occurred. One after the other, the transactions are getting executed. If one is taking more time, we stop it for some time. Okay, and we let the second transaction to execute. That is what the second point is been telling, isn't it? So we stop the T1 and grant the lock to the second TJ transaction, isn't it? So this is the preemption method of preventing the deadlocks. We have non-preemption method also. That is, instead of stopping, we allow only the first transaction to execute, isn't it? That is non-preemption method, and that name what we are going to call it as wait die scheme. Wait die. Important question, prevention strategies. What are the two methods? Wait die and wound wait. These are the two techniques. Wait die comes under the non-preemption. Non-preemption means we don't stop the transactions. Okay. Now you can read out the first point. Now suppose in this scheme, suppose Ti is requesting for the resource X that is locked by Tj. It means that Ti wants to read a data item which is locked by second transaction Tj. Okay, then the system will be checking the time